Hello everyone, so today we're going to talk about alkanes and this is our mind map.
The general formula for alkane is CnH2n plus 2 where N could be 1, 2, 3 and infinity. Only single covalent bonds are present in this hydrocarbon compound. Alkane is also known as saturated carbon because the number of hydrogen is maximum that can bond with the number of carbon atoms. We can also assume that alkane is sp3 hybridized.
Before we talk more detail about alkane, first we're going to learn about the naming of alkane. So first step is we have to find the longest continuous chain of C atoms, which we call as parent name. And before that, we should know each of the nomenclature of alkane. So we start with 1C, we call as met. 2C is et, continue with prop, but, pen, hex, hep, oc, non, and 10C is dec. Alright, going to the second step, we should identify the name of the substituents. And if the location of two different substituents are the same from the both end of main chain, assign the lower number alphabetically to the first substituent. And if two or more different substituents are present, write them in alphabetical order.
Now let's look at halogenation.
The reaction of mechanism in alkane is halogenation of alkane. Alkane halogenation is an example of substitution reaction. Halogenation mechanism involves three steps. First is initiation step, which is light is supplied for homolytic cleavage. Next is propagation step. The chlorine atom collides with a methane molecules and remove hydrogen, forming another free radical and other products. The methyl free radical collides with another chlorine molecule, producing the organic product and regenerating the chlorine radical. And the last step in this mechanism is termination. Two free radicals will join together and producing a non-radical compound. Combination of a free radical with a contaminant or collision with a wall are also termination steps. Catalytic cracking and hydrocracking are processes used in petroleum refining to crack heavy, long-chain alkane feedstocks into lighter, shorter-chain alkane feedstocks. Catalytic hydrocracking are used for converting high boiling point hydrocarbons to more valuable lower boiling point products. For example, dodecane can be cracked to form pentane and heptane with high temperature and a catalyst like alumina. Catalytic cracking is a reaction in which larger saturated hydrocarbon molecules are broken down into smaller, more useful hydrocarbon molecules. For example, dodecane can be cracked to form pentane and heptane uses a temperature of approximately 550 Celsius and a catalyst known as zeolite which contains aluminium oxide and silicon oxides.
Thank you, AFIZEA. So right now we're going to talk about reactions in alkane. The first one is combustion of alkane. Alkane react with oxygen in combustion reaction, usually to produce carbon dioxide and water. Alkane makes very good fuel when they burn because they release a large amount of heat. As we can see from the table of enthalpy change value, in combustion reaction of alkane, we can see that all the values are in negative. Why? Because it is combustion reactions and they are in exothermic reactions, which they release heat. There are two types of combustion, which are complete combustion and incomplete combustion. The first one we are going to look is complete combustion, in which an alkane burns in excess of oxygen. So here we have the reaction of C3H8, which is propane, with excess oxygen to produce carbon dioxide and water. Next, we look at incomplete combustion, in which an alkane burns in lack of oxygen. So once again, we look into this incomplete combustion of propane. With lack of oxygen, it produces carbon monoxide and water. Alright, next up, we'll look through hydrogenation of alkane. Actually, hydrogenation is one of the methods to prepare alkane. And hydrogenation is one of the most easiest method to prepare alkane from alkene and alkyne. Alkene are compounds with double bond. So basically, an alkene will break the double bond and add hydrogen into the compound with presence of catalyst with certain temperature and becoming an alkane. So here we have the reaction of C2H4, which is ethene, with the presence of nickel as catalyst in temperature 200 degrees Celsius to 300 degrees Celsius. It will break the bond and become ethane. The hydrogenation also can be carried out with the presence of platinum and palladium at room temperature. So, last but not least for today's reaction is decarboxylation reaction. Decarboxylation is a chemical reaction that removes a carboxyl group and releases carbon dioxide. Usually, decarboxylation refers to a reaction of carboxylic acids remove a carbon atom from a carbon chain. In this reaction, carboxylic acid is treated with soda lime, which is a mixture of sodium hydroxide and calcium oxide, and forms our main character for today, which is alkane. The decarboxylation mechanism replaces the carboxyl group in a carboxylic acid with hydrogen. The reaction is facilitated by a group of enzymes called decarboxylases or carboxylases. So, the mechanism of the reaction takes place in 3 steps. The first one begins the removal of H+ ion from the carboxylic acid and the addition of Na, which is sodium. Sodium salt of the carboxylic acid and water molecule was released in this step. In the second step, a negative charge from oxygen is moved in between the carbon-oxygen bond. So, the bond between the alkyl group and the carbon breaks. CO2, which is carbon dioxide, will be liberated in this step. And the third step takes place in the help of H2O, which is water that generated in the first step. It breaks to give proton ion that combines with an alkyl group to give an alkane. That's all for carboxylation reaction. Isn't it easy? And that's a wrap for today's reaction.